In this video, we are going to study elementary row transformation, and this time I'm taking a 3 by 3 matrix. So I again start with A is equal to IA, and this was the original matrix which was given to me, is equal to IA. And therefore, what is my aim? The first thing that I require over here is somehow to convert this element into 1, because I need to convert this into a 1 0 0. Fortunately, we already have a 1 over here. So now my aim is to convert these two into 0. And I will take R2 tends to R2 plus 3R1, and same ways R3 tends to R3 minus 2R1. And let's see, what are we getting? No change in R1, 1, 3 and minus 2 over here, and a 1, 0, 0. Now let's look at R2 plus 3R1. This is going to give me a 0, and R2 plus 3R1 is going to give me a 9 and minus 11. And here R2 plus 3R1 is 3, 1 and 0. And for the last line, that is R3 minus 2R1, this will become 0, this will become minus 1, and this will become 4. And this is a minus 2. Next we have a 0 and 1. If you are not very fast with the mental calculations, please see to it that you make a rough column and then start solving. So you can see here I have converted this first column completely into a 1 0 0. Next, my aim is to convert this into a 1. Once I convert the centermost element, and these two can be converted easily into 0. To convert this one into a 1, it is advisable that you use only row number 2 and row number 3, because if you touch this row number 1, this element is going to change. So use row 2 and row 3 to convert this into a 1. Now I know 9 minus 8 is equal to 1. So what do? 9 minus 8. So I need to multiply R3 with a 8. And I am doing an operation R2 tends to R2 plus 8 R3. So there is a change in R2, no change in R1 and R3. I am writing those first, is equal to 1, 0, 0 and 0 minus 1 and 4 over here, and minus 2, 0, 1 and A, and this one is 0, and 9 minus 8 is going to give you a 1 over here, and I have a 4 8s are 32. 32 minus 11 is 21, and again let's write this properly, a 21, and this one is 3, and this is a 16 minus 16, so I get a minus 13 over here, and this one is 1 and this one is 8. Next, since I have converted this into a 1, my aim is to convert these two into zeros. So I take R1 tends to R1 minus 3R2, and R3 tends to R3 plus R2, which is going to give me further. Let's see, what are we going to get here? No change in R2. I'm writing R2 first. 1, 0, 1 and 21, and this side is minus 13, 1 and 8. I'm doing an R3 first because R3 plus R2 is a smaller calculation. So I get a 0 over here, and I get a 0 over here, and I get a 25 over here. And here I get a minus 15, R3 plus R2. This is a 1 and this is a 9. Now let's look at the elements of the first row, what we are going to get. And if you look over here, we have in the first row R1 minus 3R2, and I have a 1 over here, and this will give me a 0, and R1 minus 3R2 is going to give me a minus 65. Similarly, R1 minus 3R2 is going to give me a 40, and here I'm going to get a minus 3, and R1 minus 3 R2 again is a minus 24. Now I have got a 1 0 0 as required and a 0 1 0 as required. Now what is required? This part, this one should be a 1. So what I'm doing is eventually I'm converting 1, then 2 zeros, 1, then 2 zeros, and now the last one is a 25. So I'm dividing the entire row by 25. So R3 tends to R3 by 25. Change in R3, I will write that first. 0, 0, 1 is equal to, and minus 15 by 25. So if you reduce it, you are going to get a minus 3 by 5. Similarly here, I get a 1 by 25 and I get here a 9 by 25. So I am writing the third row first and A, and here now once I get that, I'm going to fill this up with the remaining elements. Minus 65 and 0, 1, 21, and this is a minus 13 and 1, 8, and this one is a 40 and minus 9, minus 24. So all that remains is now to convert these two elements into 0 with the help of this 1. So the next step is simple. R1 tends to R1 plus 65 R3, and R2 tends to R2 minus 21 R3 should give me my final answer. There is no change in R3, so I write an R3 first. 0, 0, 1, and here we have a minus 3 by 5, 1 by 25, and 9 by 25, and A, and R1 tends to R1 plus 65 R3. We are going to get 1, 0, 0, and this one is going to give me R1 minus 65 R3, this one. R1 minus 65 R3. So we are going to get a 0. And let's look over here. If you were to calculate this, 40 into 65 and R3, something like this. So you would have got what? 1 over here, right? So you can do the calculations sideways. I've just shown you 1, and you are going to get here a 1. And same ways here you are going to get a minus 2 by 5 and minus 2 by 5, and here you are going to get a minus 3 by 5. When you look into the second row, you are going to get in the second row, which is a R2 minus 21 R3, will give you a minus 2 by 5, and here you are going to get a 4 by 25, and the last one you are going to get a 11 by 25. So this one would definitely be a 0, 1, 0. Right? I showed you this right hand side first. So if this is I and this is A, then this is A inverse. So the value of A inverse is what we have got over here. If you were to just find out the answer faster, this is something which is going to help you just to find out the answer. So what you do is write this matrix 4 times, right? This is 1, 2, 3 and 4, and just cancel the boundary to obtain the adjoint. We know A inverse is equal to adjoint of A by determinant of A. If you calculate the value of the determinant over here, the value of the determinant is to be calculated. This is a 1 and 0 plus 25 minus 3, and I get 0 and plus 10 and minus 2, and we are going to get here or minus 15. Let's see, this is going to give you a 25 minus 30 plus 30. So the value of the determinant is coming out to be 25. And here what I am going to calculate is the adjoint. So I have written the values of the matrix 4 times, and then I am just discarding this boundary and then solving it horizontally but writing it vertically down. So I'll get the adjoint directly. And therefore, if I was to solve this, first let's take this one. So what are we getting? We are getting here 0 and minus plus 25. Then this is a minus 10, and you can see here solving horizontally but writing it vertically downwards to get the adjoint directly. And this one is minus 15. And then we take the next set of 4 digits, and we are going to get a minus 10. The next one is 0 minus and minus plus 4, and this one is 6 minus 5, which is equal to 1. And the last set, so this way we are finding out the adjoint directly, is minus 15, and then this one. So though this looks kind of very intricate, but it's a very shorter way to solve the question. And this is a 6 plus 5, which is an 11, and the last one is 1 and a 0 and 9. So this will give you the adjoint of A. This part is going to give you adjoint of A, and all that you have to do is A inverse is equal to adjoint of A by determinant of A. So I am dividing it by 25, and we get 25 minus 10 and minus 15 and minus 10, 4, 11 and minus 15, 1 and 9. So this is going to give me a 1, and minus 10 by 25 is minus 2 by 5, and this one is minus 3 by 5, minus 3 by 5 over here. The next one is minus 10 by 25, so we are getting a minus 2 by 5 and 4 by 25 and 11 by 25, and this is a minus 3 by 5 and then 1 by 25 and 9 by 25. So this is a very fast way of obtaining the answer, and you can check with your last answer whether it is matching or not, and you see I have the amount of time that I have taken over here is much less. So that's it. Happy solving.